Hey everyone, ever wonder what's actually going on inside the mind of an AI? Well, it turns out there's this hidden decision maker at the heart of it all. Today, we're going to pull back the curtain and see exactly how it works.
So let's start with something you know pretty well, your own brain. You've got billions of neurons, right? And they're all getting bombarded with signals. How does a single one of them decide, hey, this is important, I should pass this along? It's a simple yes or no choice. But that choice is the bedrock of, well, everything you think. And this is where it gets really wild. AI is literally built on that same idea. We create these artificial neurons, and just like the ones in our head, they need some kind of system to decide whether to fire and pass on information or just stay quiet. And that little system is exactly what we're going to break down. So what do we call this crucial little decision maker? It's called an activation function. It might sound a bit technical, but it's really the mathematical heart of every single artificial neuron.
To put it simply, an activation function is just a tiny rule. It takes all the info coming into the neuron, chews on it for a second, and then decides what signal to send out. It's what turns a jumble of inputs into a single, clean decision. Let's look at a couple of the most common ones. First up, we've got a real classic, the sigmoid function. Now, the absolute best way to think about this one is like a dimmer switch for a light. It's not just on or off, it can be anything in between. Here's the deal with sigmoid. You can throw any number at it you want. Huge, tiny, positive, negative, doesn't matter. It'll take that number and mathematically squash it, so the output is always a nice, smooth value somewhere between 0 and 1. So what this means is, if a neuron gets a really strong, positive signal, the sigmoid function will spit out a number super close to 1. The light is fully on. If it gets a big negative signal, the output is almost 0. The light is off. And for anything in the middle, you get a value like 0.2 or 0.6, just like a light on a dimmer. All right, next we have a function that is hugely popular in modern AI. It's called ReLU, which stands for Rectified Linear Unit. And if sigmoid is our dimmer switch, then ReLU is just a simple, no-nonsense on-off gate. The rule for ReLU is just brutally simple. It looks at an incoming signal and asks one question: are you a positive number? If the answer is yes, the gate swings open and lets the signal pass right through, exactly as it is. If the answer is no, the gate slams shut. Its simplicity is really its superpower. An input of 10 comes out as 10. An input of 150 comes out as 150. But an input of -5, that comes out as a big fat 0. An input of -1,000, still 0. The gate is closed unless you're positive. So let's just put them side by side. You've got the sigmoid dimmer switch, always giving you that smooth output between 0 and 1. And then you've got the ReLU on-off gate, which gives you either 0 or whatever the original positive number was. Two totally different rules for making a decision. Okay, so we've got these simple little rules, a dimmer and a gate. But why is this the secret ingredient? Why does this all matter so much? Well, this is where it all clicks. Get this. Without these little decision makers, a neural network, even one with millions of neurons, is basically just a really, really complicated calculator. It can only learn simple, straight-line patterns. It's powerful, sure, but it's not truly intelligent. But the moment you add these simple activation functions, the network gets a kind of superpower. That superpower is called nonlinearity, and that is what allows it to learn and understand the incredibly complex, messy, and definitely not straight-line patterns of the real world, from recognizing your face in a crowd to understanding what you're saying. And that's really the key takeaway here. This tiny mathematical step is what turns a basic calculating machine into a powerful learning machine. It's what gives AI its depth and its amazing ability to tackle problems we once thought were impossible. So let's do a real quick recap. AI neurons decide what to do using an activation function. The sigmoid is like a dimmer switch, squishing values between 0 and 1. The ReLU is a gate, blocking all the negatives. And most importantly, these simple rules give AI the power of nonlinearity, which is the secret sauce that lets it learn. And that leaves us with a pretty cool final thought, doesn't it? Today's mind-blowing AI is built on these surprisingly simple ideas. So it makes you wonder, what new, even smarter decision rules are we going to design next? And what incredible new things will the AI of tomorrow be able to do?